Hello everyone, Ken here, back with part 2 of my data science fundamentals series. In the previous one, I talked about some of the basic functions and methods for data exploration. In this one, I'm going to talk about data manipulation using Pandas. You can find this all on my GitHub, all of the code from the previous video and this video. I will be linking them in the description below. I will also be putting the data set from Kaggle, where we're looking at Craigslist vehicle prices there. As usual, if you enjoy this content, please hit that like button, and please subscribe if you want to see more similar videos to this. So without further ado, let's get started. Now, we're going to be using, this is the code from the last video. I'm going to open a new file. So Control N. And we're going to save that into our working directory, which we can see up here. There's this little folder up here that lets you set the working directory, and you'll be able to see all of the files in that working directory here. So when we save this new one, so we can just do save as, and we're going to call this data manipulation 2. And as you can see, it pops up right there. So now we're going to go over and import pandas, because that's the main library that we're going to be using. And we do it, again, we alias it here, so we just have to type pd before we run our functions from it. And the first thing we're going to do is read in our data frame. So read CSV, and then I like to right click and rename, and then I just copy and paste that in. Rather than typing the whole thing, there might be an easier way to do that, but for me, that is the most straightforward. If you want to read in a file not from your working directory, you just put the whole path here, and it should read that in. So again, we can press Control Enter, and it will run whatever is highlighted. Now this will take a minute or two to read in, and when it is read in, we'll be able to see it in our variable explorer. So it looks like I have some stuff here. Why don't I restart the kernel? We'll just run this stuff again real quick, so we have an empty space for you to be able to see what's going on there. So that might take another second. You know, in the interim, if you have any questions, you have any thoughts on this, you have any ways to actually do any of these things better, please leave those as comments in the comment section below. Any feedback on this video is really appreciated. It helps me make better content. It also helps me to figure out what people are interested in learning. So now that we have our data read in, we're going to do a couple of things that are similar to the last video. So we want to see what the columns are. So right here we'll be able to see the column headers in the that we can also see up here. That's a really nice thing about using the Spider environment, IDE, is that you can get some basic understanding of your variables just by looking up here. One thing I didn't mention in the last video, which is cool, so let's make another data object, but we're just going to do the first couple rows. Let's do the first 100. It'll show up here as well, but you can double click this and it will pop out a crosstab. So you can do some really light exploration, kind of understand what's going on in your data at a first pass by looking at it. That's a nice feature that I think is pretty important to look at. If your column names aren't great, let's say you have, for example, instead of city URL, it was city space URL, and you wanted to change that, you can do data.rename, and then index equals the string, columns, and then equals. So we put the column we want to change. So in this instance, it would be, let's change city, and we'd want to change that to, let's say, new city. We would run this, and if we just ran this, it would return a data frame. It wouldn't change our initial data up here. Let's actually just change data too. I don't want to change our data up here yet. And so we add in this parameter called inPlace. We set that to true. So that means that it changes the actual data frame object that we're working on. It doesn't just create a new one, or it technically overwrites the data frame. So as you can see here, this is now new city instead of just city. I think that that's something that, you know, I learned pretty recently, and it made it a lot more easy for me to actually work with and manipulate some of the columns. You know, I hate it when a lot of data sets, they have columns that have spaces, and that really bothers me. So if it's only a few of them, I can go in and change them really quickly like that. You can do this, you can pass in a list here. So rather than just one city, you can do it like that and pass in multiple. That works as, one column. So you can pass in city, URL a couple, and change those there. So the next thing that I think is relevant to look at is, let's say we just wanted to look at one column of our data set. We can do data, and then we just put in brackets the column name. So let's say we just wanted to look at city. If we did that, we would just have our cities included there, which is pretty nice, pretty straightforward. It lets us cut through just individual columns like that. So if we wanted to just look at rows, I think it's a little easier if I comment these. These are all really commented on the code that I put into GitHub. You should be able to get a really good understanding of those things there. We can do 0 to 100, and that'll give us the first 100 rows. So Python starts with indexing at 0 instead of 1. R starts at 1, so that's something to take notice of. If we do that here, if we just run these, it'll give us the first 100 rows. So yeah, sorry. I was like, oh, where'd it go? So this has all of the columns, all 22 of the columns. It's just that first 100 rows. Looks like I ran it twice here. Awesome. That doesn't look good. The descriptions are very interesting. That's maybe a conversation for a data cleaning one, where you could maybe filter out all of the Spanish ones, or try and do something really cool like that. The next thing that is relevant is selecting multiple columns. So whenever we're analyzing data, we usually want to remove the columns that aren't relevant to us. And sometimes we want to remove a lot of them. Let's say we only want to keep like 3 or 4 columns. So when we do that, we can do data, and then we do double brackets. So we're passing a list in, and we put in a list of a couple column headers here. So let's say we want to remove, we just want to have URL, we just want to have city, and we just want to have price. And so we can set this one to URL, city, price, just for our records. And just like that, you have this data frame that only has those 3 columns. So it's really nice to be able to trim things down like that. There's a couple other ways to do this, which I think I should note. So URL city price 2, and we can use the location command. So it's data lock, and with this, it allows us to also filter on the rows we want. So in the first one, let's say when you do a colon, it includes all of the rows, and then we do the exact same thing where we do URL city and price. And so this should give us the exact same thing. Let's say we wanted to filter on just a couple rows. We could change this from 0 to 100, and we get that same thing, but with just those first 100. Looks like 101 rows there. Now, I think that's pretty cool. But if you wanted to look at it by just using numbers, let's copy this. We're going to use the ilock, which is the integer location. So instead of passing in an array here, we're just going to do the column numbers. So we're going to do 0 to 2. So that's going to do the first 3 columns, I believe. I have to change this to ilock. Here we go. What did I do here? Little extra bracket never hurt anybody. Perfect. So, sorry, I have to do 0 to 3. Even though I've been doing this a long time, I still mess up some of the small things like that, but again, a nice thing about Spider is you can just look up here and you can evaluate it and see where you messed up. So again, we have city URL. We wanted to do price, but that's something we can adjust at a later time. I personally like being able to see the column names. That's a little bit easier for me. That lets me pick and choose exactly what I want. The integer location is like, oh, I want this, these specific columns. If it's, let's say, like 20 columns that you want to include, it's probably easier to do it this way rather than typing them all in. Another thing that is relevant, which could save you time as well, is dropping columns. So let's say I have a really big data frame, but I only want to drop 2 or 3 columns. It doesn't make sense for me to go in and type in all of these things. It makes sense for me just to drop the ones that I don't necessarily want. So to do that, I can do data.drop, and then I pass in the columns that I want to drop. So let's say I want to drop URL, and for this I have to set drop doesn't know if we're dropping columns or rows. So in order for it to know that I want to drop columns, I do axis is equal to 1. So if I did axis is equal to 0, then it would drop rows that had an index of URL. So the index is the same thing as like a column header, but on the I guess on the x-axis. So doing this, we'll get a full data frame that just doesn't include axis, right? So you can see it has 21 columns here. If I set this to a variable, so data no URL, we'd be able to see that everything is the same except it does not have URL here. And we probably want to keep in URL. I think that that's the unique identifier. That's why I didn't do that here. If we wanted to change that in data, we would, without making a new data frame, we would do that same in place is equal to true up here. So that would adjust the same data object that we have up here, again, which we don't exactly want to do. Now, we've talked about dropping columns. Now it's time to talk about actually adding columns in. So let's say I wanted to look at, let's do something fun. So like the year of, the age of the car. So we have the year that the car was made, but in order to get the age of the car, we have to subtract that year from 2019. So let's make this new column. It's called age. And to make a column in Pandas is really easy. You just basically make a new one like this. You just put what you want the column name to be in the brackets, and then you set it equal to something. So for us, it's going to be 2019, which basically creates a series of 2019 for all of the inputs, and we subtract data dot year from it. So with this, as you can see, now we have 23 up here instead of 22, and we can run data.age, and we can see that these should all be hopefully less than 50 or 60. This is probably a very old car right here. And it's that easy to make that column. Let's say I wanted to just make one for what the current year is. I could just set this equal to 2019, and it would make a column that has 2019 for every value, just like that. Alright, so this is going to be column creation. Moving forward with that, I think the next relevant thing is figuring out how to filter your data frame. Let's say I only really want new cars. And we'd say new cars are age less than 10. Or let's do less than or equal to 10. So right now we're going to be filtering by this criteria. So in order to filter, let's make data new cars, and we're going to take our data, and we want to set a Boolean, like a true false, inside of this inside of this data append. I mean, not this data append, this data object. So we're going to take that data dot age, that we just created, and we want it to be less than or equal to 10. And if we do that, we should be able to trim our data frame. So we have 250,000 cars that are new by this criteria that I set. If we want to filter on a couple things, we do the same thing, and we just add a parentheses. And let's say we want to do that, or let's say or. Where is my? We do that for or, and then we also want data.price. Let's say we want that to be greater than 5,000. And this will be new cars price. There we go. So now we have slightly more because we have our price as an or. If we didn't end, it would very likely be less unless all of the new cars had a price over $5,000. So that's a pretty straightforward, simple way to do things. You can also do this exact same thing with the location statement. So we can do data dot lock, and in where we had the first column where we'd select the rows, we can put in this same information. So we can do data age greater than less than or equal to 10, and then we do a comma and colon because we want all of the columns still. So that should provide the exact same information there, which is a pretty simple, straightforward way to do things. Something that I probably should have mentioned up here is for all of the basic operators like addition, subtraction, multiplication, and division, we can use our columns to we can do those operators against each other. So I can like add year to price, or I can look at price by mile. So let's do that. So let's take new feature creation. So we already created age, but let's do like price per mile on the speedometer. So data, we do price per mile, and for that we do data press insert price divided by data, and then I think odometer is one of them, which is just the number of miles on the car. And so now we get this new feature. As we can see, it's included up here, and we'd expect there to be more miles for the most part than the price of the car, except this one. So that might be something we identify. Oh, that could signal that it's a good deal or something like that. Part of this new feature creation is to actually build new features that are useful to us. For example, if we wanted to signify that something was expensive or inexpensive, we could do some binning, or we could set a criteria and apply a function that we make to all of the values in one of these columns. So we're actually going to use this apply function, which I think is really useful. And so like, let's say we wanted to make a column where the price was doubled. We could do it this way, where we just up here, here, where we multiplied price times 2. But we can also do it using this apply function, which gives us a bit more flexibility. Let's say we wanted to do an if-then statement related to it. We could do that here. So let's do data, and then let's call this price 2. And then this is equal to data.price. Remember, this data.price is the same thing as data price. Oops. Great. And then we do apply, and then we do sum function. Now let's write a function. So this is how you write a function in Python. So it's def, and then let's do price 2x, and then we pass in a parameter, and then we have to return something, or we need to in this case return something. Return, and then x times 2. Great. So then right here we would just pass in price to x, and if we look at data.price.head, we can see that for the same thing, all of these values are double this value. So our function worked. So instead of going all in and writing this function out like this, we can use what's known as a lambda function, where we just write the function in one line and pass it in. So we don't have to create and instantiate this function. So I use lambda functions all the time. It's just a lot quicker for me. And they're Python. You can pass in functions, which is a cool feature of the language. That's not common in all programming languages. So we can do the data. Let's call this price 3, and that's going to be equal to data.apply. And so the way we create a lambda function is to do lambda x. X is the parameter, and then we can just do x times 3 this time. And so that's gonna, for every number in that column, it is gonna multiply it by 3. And so this might take just a little bit longer because it has to effectively loop through everything. Oh, sorry, we have to do data.price.apply. That's going through the whole data frame there, which is not what we want to do. That's why it took so long. There we go. So as you can see, if we want to look at, let's run these two again so you can see what they look like. Data price3.head, and it should be, each of these values should be 3 times what was in the first column. So really pretty straightforward way to do that with a lambda function there. If we wanted to say filter by a couple different criteria, or let's say we wanted to convert, let's do that example that I brought up before about expensive versus not expensive. So we're going to use what's known as a ternary operator, which is like an if-then statement. You can do the same thing with a function and write it there. You can write an if-then with a parameter pass in, but I like this approach if you're comparing two things. I think it's a bit more elegant. So I don't remember how to spell ternary, so I'm not going to embarrass myself, but let's two categories from price. So right here, we're going to, let's say that over 10,000 is expensive, and we're going to make a feature that shows that. We're going to data.isExpensive, and then we're going to do data.price.apply. And so this is how the ternary operator works. We say what we want to return if the if statement is true. So expensive is what we want to return if, I'm sorry, we need a lambda function in here. Sorry, so lambda x. So expensive if x is greater than 10,000, else cheap. So now this is expensive function will have a string variable. It'll either be expensive or cheap. Usually we do 0s and 1s, but for this use case, I think it's good to show it in this way. And so let's do data is expensive is dot head, and hopefully we'll have one that is expensive and a couple that are cheap. So those are all cheap. Let's do 100, and we'll make sure, we'll validate that there's something perfect. So we see that we have a reasonable amount of expensive, reasonable amount of cheap. If we wanted to see how many of each we had, we can do dot value counts, and that'll show us how many cheap and how many expensive we have. So majority are cheap, you know, about like 3/10 are expensive in that use case. There's one thing that I think is really important. I constantly find myself Googling this because I forget how to do it. You can make a new column based on information in 2 other columns. So let's say I wanted a new and cheap car. I wanted to be able to categorize those. So we can do data new and cheap, and I can actually use the values in those two columns to evaluate that. So I do data, and this time I'm doing data, I'm not doing price, right? So I'm reading in the whole thing. So I do apply, and then this lambda function, lambda x. And so I can do yes, if it's new and cheap if x, and then we want price. So we can index on x if we pass in the whole data frame is less than 10,000, and x age is less than 10, else no. And then for this we have to set the axis equal to 1, because the function will not know unless we do this if we're doing this operation on the rows or the columns. So again, axis equal 1 lets us know that we're doing the columns here. And so this might take a little while to run. It's a little bit more of a complex operation because we're passing in the whole data frame. But now when we look at this, let's copy this and put that there. Head 100, we should see, hopefully we'll see that there are a couple that we see yes to. Yeah, there you go, perfect. Alright, so this is going to be multiple columns. You know, this video is getting a little bit long, but there's a couple other things that I really want to make sure I include. If you want to go back and just only look at certain things, in the description I'm going to put some links to certain times in the video for you to be able to kind of go back and only pick and choose what you want to see, in case you didn't want to go through like this whole thing if there's some stuff that you already know. So the next thing I want to look at is binning. So let's say we wanted to group prices into different quartiles or quintiles or something like that. We can use pd.q cut to put things into quartiles. And quartiles means that for each group, so let's say like 0 to 5,000, 5,000 to 10,000, 10,000 to 20,000, 20,000 to 25,000, there's almost or approximately an equal number of values in that group. That's how this function is splitting things. So we'd pass in data.price, and then we'd want to see how many times we'd want to split it. So we'll do quintiles equal to 5, and that would give each value in the data frame a range that we can use to group them by. So we could set that into the data, we'll do price quintile equals to that, and then we'll have our quintiles. Oops, I ran it twice, doesn't matter. Okay, so as we can see, let's do, just to show that these all have roughly the same number of values, I'm going to do our value counts again. And as we can see, each of them have, 80-ish thousand, etc. High 80s, 88,000, 89,000 values in each one. So as we can see here, there's like a huge outlier. That's something in data cleaning we'll probably want to take out and figure out how to normalize that a bit. That's clearly like a typing error or an input error, and that's very common that you see in large data frames. So the other thing, if we want to group values into the same size bins, so as you can see, like this bin is relatively small compared to the distance between 19,000 and like 4 billion, whatever that is. If we want all the bins to have the same distance, we can do pd cut, and then we put in our data price, and let's do the same thing with 5. So there's obviously a huge range that all of these things fall into, but the distance between this and this is the same as the distance between any of the other categories. And if we do the value counts here, we'll see that one bin probably has almost all of the values. Yeah, so like almost all of the values are included here. For this use case, quartiles probably makes the most sense, but or quintiles or the qcut function makes the most sense. But this can be really useful in other ways if there are specific things that you want to specific ranges that you want to look at. You can also input what the ranges are with this cut function, but I think that's a story for another time. With binning, it's also relevant to think about, okay, how do we prepare this data for analysis? When we have categorical variables, like, for example, fuel type or transmission type or the type of car that it is, in order for them to be used in most algorithms, we have to convert them into dummy variables. So what a dummy variable is it's just a new column in the data frame that has a 0 or a 1 for a value. So let's say like fuel type. It's either like regular gas, diesel fuel, or other. So there's 3 inputs there. We would have 3 new columns, and if it was a diesel fuel car, it would have a 1 in that diesel fuel column and a 0 in the other fuel type and a 0 in the gas fuel type. So when we do this, we add a ton of columns to our data frame, and we remove the column that has the multiple different categorical values. Hopefully that makes sense. I'm going to do an example just to kind of show what that looks like. So Pandas has this thing called get dummies. So dummy vars. We'll make a little data frame here, and so we do pd, and then we do get dummies, and we pass in a data frame. So let's trim our data a little bit. So we have, let's see, price, we'll do year, we'll do fuel type. We will do, what else do we want to do? Transmission. And let's do like car type. So I think we should also not take all of them. So do head, and let's do 1,000, just so I can kind of show you what this looks like a little bit easier. So I think I spelled fuel wrong. Fuel, it's just fuel, it's not fuel type, sorry. There we go. And now we can see in this dummy variable column when I pop it out, so price and year, they're not categorical. Those are numeric, so they're not impacted at all. But we have a column for each different fuel type. So I guess there are a lot more fuel types than I thought before, but there's only one column for each type. Same thing with transmission, you have automatic, manual, and other. Hopefully we shouldn't see too many others. And then the car types each have a column as well. So this is how we would be able to pass data into one of our algorithms to make it understandable for most things. The last 2 things that I want to cover are really important. It's about how to manipulate the data frame to see columns and outputs that you want. So one is using a pivot table, very similar to how you would do that in Excel. And the other component is kind of SQL type commands to let you manipulate data that way. So let's say I wanted to look at like the price of the car based on the year and the type of the car. So I would use a pivot for this. So I'd want to look at like the average price of the car, for example. So in order to see that, I would do pd, and I do pivot table, and I would include my data. The next thing I want to do is set the index. So that's basically what is on the x-axis, equal to, let's do year. We do columns, which I think is pretty self-explanatory. We'll set that equal to the car type. And then the values is equal to the price. So on the x-axis, we're going to have year. On the y-axis, we're going to have year. On the x-axis, we're going to have columns. The values are going to be equal to the price, and the price is going to be average. So we have to set the ag function, which is the aggregation function, equal to mean. So now when we run this, we should have for each year what the average price of each car type is. So this is a truck. So for a 2020 truck, it's pretty expensive, $61,000. But as we'd expect, it pretty much goes down the older the car is for almost everything. I think that's pretty cool. If we wanted to, for example, sort any of these things, so it was the other way around. It wasn't oldest to newest, it was newest to oldest. We could do sort index, and then we'd set ascending equal to false. And so that's going to give us the same thing, but it's just sort of the other direction. You can also do sort values to sort based on one of the column names rather than on the index. This is a pretty cool way to do things. We can also do, we don't have to do mean. We can also look at the count for how many are sold in each one. There you go. So it's the same thing, but this is just the number of, the number of these that are being currently sold, not actually purchased. If we wanted to see what this looks like, I talked a little bit in the last video of how to graph. You can just do plot, and this will show whatever graph that Pandas thinks is most relevant here. So we can see that over time, we're looking at the volume sold, or the volume posted for each year of these different types of cars. That's a pretty neat way to look at it. I think that's a pretty good chart for just a stock chart that's built into here. Similar to pivot is the group by function. We use this a lot, especially in SQL. And so that means that we can just group by a single thing. So let's do call this grouped data. And that's equal to data.group by. And then we select what we want to group by. So let's, in this case, do type. And you can see that when we run this, it's just an object, right? So when we group by things, the backend doesn't actually know how to handle that. So we have to give it what we want to see, how we want to see the values aggregated, just like in this ag function. So if we didn't include agfunc, it would default to mean. If we don't include anything here, it defaults to nothing, and it just gives us an object. So if we want to return the average of all the continuous variables based on that grouping, we would do it like that. And then we'd show this. And it takes all the continuous ones, so price, year, odometer, latitude and longitude, age, and these things, and it would show the average for each year. For each type, I apologize, which is pretty cool. We can also group by, and notice that the type, that we're indexing by the type. If we don't want to index by something, we just do let me refresh my memory here. It's been a while since I've done one of these. As index equals false. And it now includes the type as a column instead of what it was as the index there. You usually want to have numeric indexes. That makes it easier to sort and understand. So just keep that in mind. When I group by, I almost always use as index. With that in mind, you can also group by multiple things. So we could do type and let's say like year. And if we put it in a list like this, that will also work perfectly well. There's only a couple other things that I want to include. I think these are pretty relevant. If you have two data frames and you want to join them, you would use pd.merge. And let's just create two really quickly. So we'll do data frame 1 is equal to data URL and the city. And so we're going to join them on URL here. And so URL is a unique identifier. And so if you take two data frames, what's known as an inner join is you take all of the values for URL that are the same in both data sets and combine them. So we're going from two data frames with 2 columns to 1 data frame with 3 columns. And we're going to use price here and call this data frame 2. So let's run these two. And in order to join them, we'll do df joined. And so we do pd.merge. We take the first data frame, take the second data frame, and then we have to say how it's defaulted to inner, so we actually don't have to say that, but we have to say what it's on. So we do on equals, and then we're going to do URL. And so it's matching all of the URL values for each data set. And then we get df joined. Again, we have 3 here. And you can see that the columns are URL, city, and price, URL, city, and URL, price. Those are just combined on URL, which is a really nice, simple way to do that. You can join on multiple things if you want to, just like you would be able to in SQL. I think there's only one other thing that I want to include, and that is the data appending. So let's say I have two different data frames that have the same columns, but I want to combine them together to make like one larger data set. What I can do is appending. So let's take just a sample of our data. So we can do data sample1, data.sample. Let's take 100, and we're going to set random state equal to 1. So when we set random state equal to 1, it randomly selects it, but if we always use random state, it'll select the exact same thing. So we're going to do the same thing with sample 2 and set that to 2. So we have these 2 samples of 100 rows. Now, if we wanted to combine them vertically, we would just do so sample1 dot append sample 2. And so now we should get 200 rows instead of just 100 in each with the same amount, 30 columns like we have up there. If I wanted to say, save this information to a new CSV, I did all this data manipulation, I want to give it to my friend to analyze, I can just take, let's just say, for time's sake, 1,000 rows. I do dot to CSV. I call it top 1,000 because .csv, and I run this, and it will send this to my working directory right here. So it's a great way to take it out after you've loaded in the data and analyzed it. That's it for this video. It was a little longer than I'd wanted, but there's a lot of things that I really wanted to make sure were in here. Thank you so much for watching, and stay tuned for part 3 of this series, where I'll be going into some data cleaning and potentially some analysis as well. As always, good luck on your data science journey, and have a great one.